All right, if everyone's ready, let me start off by introducing myself. Hello, my name is Lance Zurich, and I am the product manager for the Fischertechnik division over here at Studica. And today I'm going to give you a brief overview of the Fischertechnik STEM Prep 2.0 and STEM engineering sets. Now, these sets were designed to enable educators to provide students with a project-based, standards-focused curriculum program involving inquiry, design, and problem solving. The curriculum for each of these sets was created especially for Fischertechnik by noted educator and STEM expert Tom White. So, what is STEM? Well, of course, most educators are pretty well aware that the term STEM is an acronym, the letters of which stand for science, technology, engineering, and mathematics. Now, if you're involved in any aspect of education, you really probably can't open your email box any given day without seeing STEM highlighted in the subject line of at least one of your messages. And you really can't read an educational journal or visit an educational conference back when we could do such things without being bombarded by references to STEM. The reason for this is, of course, really pretty simple. To quote the Bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education, STEM education is necessary because it helps provide the scientists and engineers needed for future development. It provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens, very important. Now, as such, STEM education could really be considered kind of a matter of national security. On every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us both as individuals and as a nation to understand and keep up with these rapid changes in technology that are going on. Changes which in turn are altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments occurring all around the globe, where countries like China and India are making major investments in state-of-the-art infrastructure. And while all that's well and good, and while we should, of course, all strive to be good citizens, that goes without saying, many students might bring a little closer to home and ask, so what's in it for me? Why do I want to study engineering? Or why do I want to study coding? Or what have you? So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. Now, these projections that they had come up with indicated that STEM occupations should grow by 17%, compared with 9.8% growth for all other occupations. In March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which took a look at how these numbers were playing out up to the year 2015. And at that point, that was with 3 years still left in the initial projection. Now, what they found at that time was that while the projected STEM growth, once again, just up to that point at the end of 2015, was as expected up significantly, just a little bit less than they were, of course, expecting to reach in total by the end of 2018, what they found was that the growth was up so significantly. It was up 14%. Now, compared to that, the actual growth for non-STEM jobs, which again they were expecting was going to reach 9.8%, had only instead reached a fraction of that growth. It had only reached 1.7%, a pretty stark difference. Now, it'll be interesting, of course, when they get the final numbers on all the way up to 2018, but that's what we have so far. Now, here's a statistic that I'd like to share that should give anyone entering the job market of the future pause, and this comes from J.D. Chesloff in his Education Week article from March of 2013. To quote Mr. Chesloff, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes in his article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Now, going back to that STEM Jobs 2017 update released by the U.S. Department of Commerce, which I referenced a few slides before, Here are 3 key points that are mentioned in the report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point 1, STEM workers command higher wages, earning on average 29% more than their non-STEM counterparts in 2015. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs. These are, of course, the first things we think of when we think of STEM, things like scientists or engineers or what have you. To go on, quote, STEM degree holders enjoy higher earnings regardless of whether they work in STEM or non-STEM occupations, end quote. Now, related to this, there was a video that I ran into recently on YouTube, and it was posted by the Women's Forum for the Economy and Society. And the title of this video I thought really summed up things nicely, and that title was, quote, every company is a tech company. Now, what do I take from that? Well, essentially what students want to keep in mind is that whatever a company makes, whatever a company sells, whatever service it performs, at some point, STEM skills are required to help that company fulfill their mission. Anyway, moving right along, key point number 3 relates to job growth. Employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, 24.4% versus 4% respectively, and STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations. So with all of this in mind, the trick for educators is to find methods for getting students involved with STEM, and in particular, the most highly in-demand technology-focused skill areas, things such as engineering and coding, and to get the students involved in a way that engages their interest and their creativity, but while at the same time it develops the work habits, the way of approaching problems, and the skills that they're going to need to draw on as they move forward in their careers, both their academic and their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur, and students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. Now, how do they do this? Well, they do this through experimentation, research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on project-based learning. And that brings us right up to the focus of this webinar, which is, of course, the Fischertechnik STEM Prep 2.0 and STEM engineering sets. Now, both of these sets have been designed to provide a guided, project-based learning experience, complete with detailed standards-focused curriculum using the unique Fischertechnik building system. So what makes Fischertechnik so unique? Well, just to provide you with a little bit of background. Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block in the Fischertechnik system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place, and the hundreds of different parts available will also help students to address very specific design needs. Fischertechnik was created back in 1964 by German inventor Arthur Fischer, noted for countless innovations that are used in the construction and automotive industries. Now, Mr. Fischer, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, and he was also the creator of the expanding nylon wall plug, circa about 1959, I believe, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls, and of course, we've all used variations of them in our home. Now, his company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, and they also produce many components that are used in the automobile industry. They also provide consulting services regarding the various state-of-the-art manufacturing processes. Now, at this point, I'd also like to mention that Fischertechnik was the very first construction set of all the construction sets out there that offered students the ability to build and program their own robots. And that was originally using the original pre-Macintosh era Apple computer, so going back a few years. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related concepts. These are, of course, things like robotics, renewable energy, mechanics, optics, physics, pneumatics, and a lot more. Now, Fischertechnik has also been used by numerous companies, to name drop a couple: Porsche, Daimler Chrysler, and BMW, for industrial simulation and training purposes. Now, in addition to this, over the last few years, Fischertechnik's line of pre-assembled simulation models have found wide adoption for demonstrating and exploring the world of IoT, which is, of course, also known as the Internet of Things, where industrial processes can be monitored and controlled from the cloud. Now, as such, more than being just something that students are only going to use for a year or two in their development, you can really think of Fischertechnik as being designed so that students can grow along with it. Essentially, as students progress through their academic careers, they can also progress through the various levels of Fischertechnik education solutions which are available. Now, the Fischertechnik STEM Prep 2.0 and STEM engineering sets are two of the most important members of the Fischertechnik education family. STEM Prep 2.0 is designed for exploring essential aspects of technology with a focus on physics, robotics, energy, and power. STEM engineering is designed to provide a comprehensive overview of robotics, coding, and automation systems. Each of these STEM-focused sets is designed to provide all the materials you need, and by that we mean both the physical materials and the instructional materials, all of the materials you need to enable teachers to offer a complete daily STEM-focused classroom experience. STEM Prep 2.0 contains over 75 academic hours of curriculum material, and STEM engineering contains over 150 academic hours of curriculum material. So essentially, if you offer your students a STEM education class of a single 50-minute period each day for 5 days a week, this would provide you with enough curriculum material with the STEM Prep 2.0 set to cover half a year. And with the STEM engineering set, this would provide you with enough material to cover a full academic year. Now, the curriculum for each of these sets comes in a handy PDF format. There's a curriculum PDF for the teacher to conduct the class, and there's also a separate PDF document that can be shared with students and which acts as a guideline for the class activities, and it helps everyone to stay on the same page. Now, to assist new users of the Fischertechnik system, the curriculum also includes a helpful tutorial section. This section provides guidance on identifying the many types of parts that are included. It shows you how these parts fit together, and it also walks users step by step through the building of a simple model. The STEM Prep 2.0 and STEM engineering sets are also designed to be somewhat dual function. Well, what do I mean by that? Well, besides being designed so that educators can conduct a curriculum-centered, project-based STEM class, they also include full-color step-by-step assembly manuals in PDF form from various popular Fischertechnik STEM-focused education sets. Now, these assembly manuals can, of course, be used as a reference when the students are going to be creating their own original projects, which they are going to be asked to do during the course of the curriculum documents we'll be talking about. But they also allow you to build all the models shown in each of these manuals with the parts that are included in these sets. Now, in fact, the STEM engineering set allows you to build all of the models found in Fischertechnik's 3 most popular robotics sets. And the STEM Prep 2.0 allows you to build all of the models found in 8 different Fischertechnik STEM education sets, as well as the robotics BT beginner set. And we'll get into the details a little bit later. Now, as I mentioned at the very beginning of this presentation, the curriculum material found in the Fischertechnik STEM Prep 2.0 and STEM engineering sets was created by a man named Tom White. Now, Tom's a noted educator who's been involved in STEM education since the 1970s, and he's been designing programs for educational institutions and for industry use since that time. Now, in fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other related topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this isn't the first time that Tom White has created curriculum around Fischertechnik. Besides also being the creator of the curriculum used in our elementary focused Introduction to STEM series, and our other project-based offering, the robotic competition set, each of which are the subject of their own webinar presentations. If you're so inclined, you can of course sign up for those. But besides all of this, Tom has also incorporated Fischertechnik in many of the educational programs he's designed over the years for use in schools and for other programs. Now, Tom has often said that he believes that Fischertechnik is the ideal construction set for any kind of engineering-based curriculum program, and he's given us several reasons for this feeling. First, he really likes that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different. He also likes the versatility of Fischertechnik and the fact that it offers so much more economy than purchasing, let's say, just one expensive piece of equipment. Let's say just a robotic arm that, you know, maybe teachers would perform a couple experiments with their students, but by and large, it's going to go sit on a shelf and get dusty till the next semester. Instead, with Fischertechnik, you can build something, use it, move on to something else. That's the nice thing. He also appreciates the fact that the Fischertechnik system, with its wide assortment of very specific mechanical and structural parts and components, offers students almost limitless creative opportunities. The curriculum for both the STEM Prep 2.0 and the STEM engineering sets has been designed to address some of the most widely recognized academic standards that are currently in place in the United States. Now, this includes the college and career readiness standards for math, science, reading, and writing, the NSES content standards, standards for technological literacy, ISTE standards, and the next generation science standards. When Tom White put together the curriculum for these two sets, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, he sees his own strong point as being the creation of curriculum such as this more so than, let's say, conducting a lecture. But in any case, he focused on creating a curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class so that they could instead focus on the needs of the students. Materials have been included at the beginning to familiarize new users with how the system works. And each section of the curriculum clearly spells out how things will be covered in that unit. Essentially, this was designed to be a turnkey solution that would provide everything teachers would need in one place. So really, if teachers work through the tutorials and also review the material before they present it, most of this is all laid out so that it'll be very easy to present. In short, the curriculum was designed to provide a clear roadmap for both the teachers and the students, where the learning is facilitated through the extensive use of projects and problems for the students to address. Now, the goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems, and which contain embedded academics. Now, the detailed curriculum with each of these sets, if followed, will allow educators to provide what is essentially a standalone project-based STEM education class. Now, of course, as I mentioned before, each set also includes the step-by-step instructions for building the models found in various topic-focused Fischertechnik STEM sets if one wanted to approach it that way. Now, under this project-focused model that I'm mentioning, students are told upfront what they will need to learn and understand. They are given a real-world scenario where they have to take on the role of a professional working on a team. They're always working in teams in this coursework. And this team has been presented with a design challenge that they must work together and devise a solution to. And they're also provided with different tools and pathways to help them achieve this goal. Now, among other things, students will be asked to perform research, and this means research both inside and outside of class. And they also have to learn extensively about the documentation process. This will be things like creating a design brief, maintaining a digital engineering journal, and so on. But once again, documenting the entire process. Now, students will also be required to collect data. They will learn firsthand how data acquisition works. They're going to learn how to process data. They're going to learn how to put data into graphs and other formats, and so on. Now, students are given a technical literacy task that's driven by the project. Fulfilling this task will require them to gain the knowledge and the tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills to successfully address the project at hand. They will devise solutions to their tasks and create prototypes, of course, using the advanced Fischertechnik modeling system. Now, where required, students will also create and install the programs needed to control their prototypes. This is, of course, any of the robotics. They will document every step of the entire project and formally present their findings as a group, including a demonstration of the prototype, and if there's programming, the programming in action. Now, at this point, we're going to start to look at the sets themselves, and what you see on the screen now is a picture of the Fischertechnik STEM Prep 2.0. Now, the prep in the name, like STEM, is an acronym. It stands for Physics, Robotics, Energy, and Power, which are, of course, the subjects focused on in this set. Each set is designed to be used by a team of 2 students at a time. The set contains 2,260 parts and components, and this includes the RoboPro LT software, the BT or Bluetooth smart controller, an electronic module, a pullback motor, a solar motor, an excess motor, a mini motor, a compressor, 2 solar modules, a gold cap energy storage unit, an NTC resistor, a photo transistor, an LED, 2 rainbow LEDs, and hundreds of other Fischertechnik parts, thousands actually in this case, all of which come packed in a sturdy Gratnell storage box. Now, the project themes addressed in the STEM Prep 2.0 set include the following: sketching and documentation, simple machines, mechanical systems, structures, conversion and storage of energy, electronics, optics, digital communication, and programming control systems. And once again, the curriculum for the STEM Prep 2.0 set is designed to provide enough material to cover 75 plus academic hours. Now, the STEM Prep 2.0 set also includes step-by-step pictorial instructions culled from 9 individual Fischertechnik sets, and those include the drive systems, the eco-energy, the pneumatics, the mechanics, the Physics 1 and Physics 2, the electronics set, the optics and light set, and the robotic BT beginner set. Now you see that little asterisk down there about the fuel cell kit. There are some models that are mentioned in the eco-energy set that do require an optional fuel cell add-on. That is not included in the STEM prep, but if you did choose to address those projects or those models, and once again, this isn't addressed in the curriculum itself, but if you did want to do those extra models that are featured in the instructions for the eco-energy, you would need to get the optional fuel cell kit, which is available separately. Next, we're going to look at the Fischertechnik STEM engineering set. Now, this set, which can be used as a follow-up to STEM Prep 2.0, or it can be used entirely on its own, is designed to provide students with a comprehensive overview of robotics, coding, and automation systems. In this case, the set is designed for use by teams of 2 to possibly even up to 4 students at a time. Now, you might wonder, why is it 2 students for the first set and 2 to 4 for this set? Basically, it's because of the nature of the projects they're going to be working on. With the STEM engineering set, the projects are more elaborate and involve more steps than many of those that are found in the STEM Prep 2.0 curriculum. And because of this, it's easier to keep a higher number of students actively engaged with the research, the building, the programming, and all the other tasks that will be required for each of the projects. Now, the set contains 890 parts components, and this includes the RoboPro software, the robotics TXT controller. It includes a Fischertechnik AccuSet, which is a rechargeable battery pack and charging unit, 2 encoder motors, a compressor, 2 photo transistors, 2 excess motors, a mini motor, 6 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 2 solenoid valves, a vacuum suction device, and once again, all of it comes packed in a sturdy Gratnell storage box. The project themes addressed in the curriculum of the STEM engineering set include the following: sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, and the fundamentals of automation and robotics. And in this case, again, the curriculum is designed to cover 150 plus academic hours. Now, there are also various activities that are included to address the following areas that come up during the course of the curriculum, and I apologize because there is a slide missing that should have mentioned the same for the STEM prep, but some of these are included in the STEM prep as well, and some are unique to the STEM engineering, but in any case, this set includes activities on sketching, schematics, Ohm's law and power, an introduction to RoboPro software, an introduction to using the TXT controller, working with flow charts, open loop and closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, subprograms, data, working with sensors such as the digital switch and the digital phototransistor, working with analog sensors, things like the NTC resistor and the color sensor, learning about the camera, using the camera to detect motion, color detection, creating a ball finder, which involves using the camera as a vision system on the robot, working with the line following tool, the encoder motors, building the control panel, learning about pneumatics, robotic positions, recording robotic positions, and utilizing existing programs and subprograms. Now, this set also includes step-by-step assembly instructions from various Fischertechnik sets. In this case, it's the 3 most popular robotics sets, they being the Robotics TXT Advanced, the Robotics and Electro-Pneumatic set, and the Robotics and Industry set. Now, once again, if you wanted to work outside of the curriculum, this set will still contain all of the parts, the software, the controller, the power supply, etc. Everything that you need so that you can build any of the 22 models that are found in these 3 sets. And what this is going to include is things like color sorting machines, pinball machine simulations, various mobile robots, robotic arms, and so on. Once again, if you didn't want to follow the curriculum and you just wanted to get a lot of building power in one place for a great price, this would be a way to do that as well. Now, at this point, as I've touched on what is covered by each of these sets, I think it's going to be most useful for everyone to show you how the curriculum for the STEM Prep 2.0 and the STEM engineering sets is structured. Each unit of both the STEM Prep 2.0 and the STEM engineering curriculum contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards being addressed, an authentic project scenario, the daily teaching plan, supporting activities, and resources. Now, to put this into better context, we're going to look at the curriculum that accompanies the STEM engineering set. Now, again, while we're going to focus on material found only in this particular set for this example, the structure of the units and how the subjects in both the STEM Prep 2.0 and the STEM engineering curriculum are addressed is essentially going to be the same for either of these curriculum elements. Now, here you see the table of contents for the STEM engineering set. The first thing I would like to note is that before we get into any of the specific units, and if you'll see just even on this page, you'll see the units on sketching and documentation and basic electricity are listed. But before we get into any of that, there's a section right up front that's designed to help any new users or teachers, any new users of the Fischertechnik system to quickly get up to speed. Now, once again, the core building blocks in the Fischertechnik system are designed to attach from all 6 sides, and many of the other parts are designed for very specific purposes. Now, as this is going to be a lot different than the simple stacking construction of many other building sets you probably are familiar with, because of that, we've included this section right up front to help increase your comfort with the system, your students' comfort with the system, and to allow both you and your students to get the most from your building experience. Now there's a section that shows how the parts fit together and discussing the pin and groove assembly method that's used. A section showing you how to identify the different parts from the core blocks to more specialized parts. These are things like clip axles, girders, rivets, angle pieces, and much more. Now there's also a section that shows you a picture of every part contained in each set, along with the name, the part number, and the quantity of that part that are included. Now this can be especially useful if you ever needed to order additional quantities of any part, or if you just want to add to your assortment. Now, for those educators who might be new to an approach such as we're talking about here, there's also a chapter that discusses specifically how to go about conducting a project-based STEM education class. Now, with that note, let's jump right ahead to a sample unit to explore that structure that I was discussing. This unit, as you will see from the image on the screen now, is focused on programming. The picture you see at the top of the sample page is a graphic representation of RoboPro programming software. Now, as you can see in this close-up, RoboPro is designed to utilize icons that represent the different actions the robot that's being built must perform, which students will arrange in a flowchart style manner to help create the programs for each of these robotic models. Now, the nice thing about using graphic programming software such as RoboPro for programming is that it allows students who may not have any prior experience with any kind of programming of any sort. It enables them to quickly become comfortable with doing so, but at the same time, it also helps to familiarize all students with the core concepts that will be found in all types of programming. Now, going back to the main page, as you'll see right under the unit title, the first thing we will encounter in each unit is a section entitled The Purpose of the Project. Now, this is the section that seeks to clearly spell out to students the answer to that eternal question, so why are we doing this? See, too often in the past, students might encounter subject matter that didn't seem to have any relevance to them. I mean, I know for myself back in high school, it would have been trigonometry. Well, either way, in this case, students are told why this material is necessary, where it fits into the larger scheme of things, and what we hope to develop here. Next, you will see the concepts to be addressed in this unit. And these are the big ideas that students should take from this project that will be essential for them to understand and utilize, not only today, but also to draw upon as they move forward in STEM fields of study and, of course, we hope, STEM-related careers. Now, following this, we see the outline. In this section, we drill down more specifically to what will be addressed in this unit. Now, again, as this particular section is focused on programming, you will see that we touch upon areas such as the methods for writing programs, things like flowcharts, word problems, etc. Program characteristics, whether it be open or closed loop, branching, whether it be digital, analog, subprograms, and so on. After this, we come to the section where each of the specific standards to be met by this particular project unit are spelled out, which of course provides the educational justification for the project itself. Now, because it's impossible to include all the standards that have been created by individual states and school districts, what we've done is we've selected the most universally accepted standards currently used across the United States today. As such, we begin with the college and career readiness math standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. After this, we have science standards, beginning with the NSES content standards for K-12, and the standards for technological literacy, which are followed by the ISTE Technology Foundation standards for students and the next generation science standards. After all, this is the assessment section, which includes links to both general course rubrics as well as rubrics related to the specific unit in question. Following that, we have the essential question. Now, this can be thought of as the broad major idea to be explored in the unit. Now, in this particular case, the question being put forth is, how can we make decisions electronically and remove the need for human intervention? After this is what we might call the centerpiece of each unit, and that is the student scenario. Now, the student scenario for each unit gives the students an opportunity to explore the unit's essential question. And this comes in the form of a real-world problem that students are given to solve and it helps to provide a tangible example of why the subject matter being explored is both relevant and important to understand. Now, in this particular example, that once again taken from the programming unit, students assume the role of a controller/programmer working at a programming company that specializes in designing elevators and writing the control packages for their clients. Now, working in small groups, which again is the way all of the projects are approached in the curriculum for either of these two sets, the students are asked to work together to design, in this case, to design an elevator that will have certain parameters, such as, for example, if the elevator was stuck on a middle floor, and let's say somebody on the top floor was pushing the call button, and somebody on the lower floor is pushing a call button, creating a protocol for where the elevator has to go first, as opposed to just being stuck in a state of confusion. Of course, you have to create a protocol, so how would address that? In any case, students will have to create a protocol in the programming to address this thing, and the client requirements, whatever other client requirements are all spelled out here, and the students will be, once again, designed to require an elevator or design an elevator that meets those requirements, create a program to address those specific requirements. They're going to build the actual elevator prototype using the Fischertechnik, of course, and eventually prepare a presentation for their fictional clients that includes a demonstration of the prototype and the program they've created in action. And of course, they have to do all the documentation and all that. Next, we have the daily plan. Now, the daily plan acts as a roadmap of sorts, and it clearly lays out the expectations as students work through the project in the student scenario. Each day of the plan acts as a guideline, and it spells out specifically what the students are going to look at that day and what they need to accomplish. Now, you see that as different concepts are addressed, students are provided with helpful links which will give them more information. For example, they will have links showing them what will be required in the design brief, which I touched on before, or that they're going to be asked to create, or what kind of information they're going to need to track in their digital engineering journal and so on, or for example, how to install and use the RoboPro programming software. And we're going to look at some of these links a little bit later. But again, each day of the plan contains a different task that needs to be addressed, a different activity that needs to be performed, or a different question to answer. For example, if you're able to look closely at the bottom of the page on day 7 that I have up on the screen now, you'll see that there is a discussion topic listed. And the discussion topic is, how does my dishwasher know when the dishes are clean? Well, of course, a dishwasher doesn't judge or comprehend when dishes are clean, but instead, it's programmed a certain way to go through certain cycles for a specific period of time. And so here, a teacher can lead a discussion where this idea can be explored further. Now, other things covered in this unit will include things like how data is taken from a sensor and recorded, or how files can be taken from the RoboPro format, put into an Excel format to be modified and worked on, and then put back into the RoboPro format, working on things like robotic positioning, and so on. Now, I will say this is one of the longer units in the curriculum, and it continues for a period of approximately 35 days total. In any case, as students work through the daily plan and on their answer to the student scenario, once again, they're going to be required to perform research. They will be required to do trial and error experimentation and document the entire process. And this means, again, maintaining a design notebook and digital engineering journal. Whatever diagrams or sketches or whatever they do, they have to maintain all of that. They also have to design and build the working prototype using Fischertechnik. Now, if the model is an automated model or a robotic model, as in the case of the elevator here, the students will also have to design the program that controls the model. Now, putting everything together, each student group will, at the end of each of these project units, create and deliver a presentation of their individual prototype in action, so their group prototype. So at the end of each of these units, you're going to have several groups in your classroom all presenting their prototypes and explaining the rationale and what have you. Now, the idea through all of this activity is that each day builds on the day before, and each activity is subsequently more complex, and also along the way provides more of the information that students will need to draw on to successfully complete the project at hand. What does this do? Well, it really helps to reinforce all the concepts, and it ties everything together in a very organic and meaningful manner. Now, there are also various supplemental materials included at the end of each unit, and depending on the unit, this can include things like vocabulary words, carefully selected web-based resources, things that have been vetted, of course, Word documents, PDF files, PowerPoints, and much more. Now, once again, each unit of both the STEM Prep 2.0 and the STEM Engineering sets follows the same structure as we've just seen here, including the standards, the rubrics, the daily plan, the resources, and so on. Now, as I mentioned before, there are also numerous links throughout the curriculum designed to provide more guidance on specific topics as they rise up. Now, besides being linked this way throughout the curriculum, these sections are also all collected in one place at the very end of the curriculum document. Now, once again, using the STEM engineering curriculum as an example, there are links providing detailed information on such things as what's required in a design brief or an engineering notebook, a section on doing schematic drawing, another section explaining Ohm's law and power, how to program a robot to detect motion using the camera attachment, digital branching, working with flowcharts, open and closed loop programs, combinational logic, working with RoboPro, robotic positioning, working with sensors, I'm stuck here, working with data, using vision systems, subprograms, and so on. Now, there's also a section where all of the rubrics for the curriculum are collected, and these are both the general course rubrics as well as the unit-specific rubrics for each individual project theme. And finally, this is followed by a section containing the step-by-step assembly instructions that I mentioned before. These are, of course, culled from the various STEM and robotic sets, depending on which set we're talking about, the STEM Prep or the STEM Engineering. Once again, the STEM Prep curriculum will share the same structure through all the units, just with a focus, of course, on different subject areas. Now, I'd like to share a few photos with you of one of the schools currently using the Fischertechnik STEM Prep and STEM Engineering sets. Now, this particular school is Westfield Technical Academy, located in Westfield, Massachusetts. And the program over at Westfield is being conducted by Dave Roberts, who's the science teacher there. Now, what you see in these pictures are the students as they address the first hands-on challenge, which is presented in the curriculum for the STEM Prep 2.0 set. Now, this is a very basic challenge, but it gets everybody started. In this case, the challenge is designing and building a prototype of a braking system as would be used on a racing bicycle. Now, again, students are going to be asked to work in small groups. With the STEM Prep 2.0, we really recommend one set per each group of 2 students to really keep everyone engaged. But with STEM Engineering, once again, because the projects are a little more involved, you can expand that group to up to 3 or 4 people and really make it work. Now, as you will see from the photos I'm sharing here, while all of the students are all working on the same project, the models don't look exactly the same, and there is no one right way. There's no single solution for addressing the design challenge given in each unit student scenario. Because of this, some of the students will design and build prototypes that work very smoothly and efficiently, and others are going to create models that might clearly need more refinement to really be practical. But in any case, the goal is to, of course, see how well the students synthesize all the concepts they've learned and how working in small teams, how well they can use their creativity and their problem-solving skills to help make something will most effectively and efficiently answer the criteria that's given in the student scenario. Now, I'd also quickly like to mention another benefit of the STEM Prep 2.0 and STEM Engineering sets, albeit it's a somewhat unintentional one. Now, a large segment of the students at Westfield Technical Academy, as Dave Roberts pointed out to me, are ESL students, or also known as English as a Second Language students. And in this case, the students are kids who originally came to the US from Russia and the Ukraine. Now, in Massachusetts, teachers are required to take classes in ELL, English language learning to help meet the needs of these students. Now, Dave Roberts, again, who I mentioned is the teacher in charge of the Fischertechnik STEM programs at Westfield, told us that he has attended 3 different ELL training classes. And all 3 of these ELL training classes highlighted specifically project-based learning as an important learning tool for ESL students. Now, the reason they gave for this is because design is really sort of a universal language, and that the act of working through the curriculum in this hands-on fashion helps to not only teach students the essential STEM-related concepts, but it also aids in building their English language skills because it helps to make the connection to actual processes and actions that they can actually understand. Now, again, what I've shared here are just a sample of some ways students can address this particular design challenge. Now, as I stated before, each subsequent unit will, of course, require more sophisticated designs, and each will build on what has come before. So at this point, just to quickly summarize what we've covered, each Fischertechnik STEM Prep 2.0 or STEM engineering set contains everything you need. It contains all the parts, the software, all the assembly instructions, and complete day-by-day curriculum. And the curriculum included in each set is yours to use this year, next year, and we hope for many years after that. There are no additional fees. There are no subscription charges. You don't have to pay next year for using anything. Everything you need is included. And again, it's all reusable. Build a model, perform the experiments, take it apart, and build another. Of course, if you ever do need any odd parts or replacement pieces, you can purchase those individually in whatever quantity you choose directly from our website. And again, the Fischertechnik STEM Prep 2.0 and STEM engineering sets are designed to make it easy for educators from any background to offer a hands-on project-based learning experience to their students. Once again, this is what experts agree is one of the most effective methods known for teaching STEM concepts. Again, the STEM Prep 2.0 set comes with over 2,200 parts and components, day-by-day project-based curriculum PDFs for both students and teachers with over 75 academic hours of material, as well as step-by-step assembly instructions from 9 popular Fischertechnik education sets for building 118 different models. Now, the pricing on this set starts at just $8.99 per set, with classroom pricing available upon request. And the STEM engineering set shown here includes 890 parts components, including programming software, the full color touchscreen TXT controller, sensors, motors, and so much more, as well as student and teacher curriculum PDFs featuring over 150 academic hours of material and full color step-by-step assembly manuals from the 3 most popular Fischertechnik robotic sets. Now, in this case, pricing starts at just $9.39 per set, and again, please contact us directly for classroom pricing. So on that note, I see there's a question here. Let me just get a drink of water real quick. Okay, from Mark Weinstein, his question is, I have 5 sets of Mechanics 2.0. Is there similar curriculum, rubrics, etc. for these sets as the STEM Prep 2.0 and STEM Engineering 2.0 that you reviewed today? No, there is not. Unfortunately, Mark, while, as I mentioned before, parts from the Mechanics set are included in the STEM Prep set that we looked at before, the STEM Prep 2.0, so it touches on some of that. But no, the curriculum is only available with these specific sets. We don't have the full-blown curriculum for those other sets, although, of course, as you know, there are teaching and activity materials. Some of the sets include those in a printed form. Other sets, you actually have to go to the fischertechnik.de website, that being the German website. And there is usually a code right in the instruction booklet where they have teaching materials so that you can just go in there, punch in the code, and then you can download the materials that they have available online. But no, as far as, you know, curriculum-based resources, standards, rubrics, all that, anything project-based for specific sets like the Mechanics set alone, no, that's not available currently. If anyone else has any other questions, this would be a good time to type them in. Anyone? I will move ahead to the next slide so you get the email addresses here. If you did want any more information on anything that we're offering here, if you'd like to request a quote, if you'd like to speak to me, or if you'd like to speak to one of the dedicated educational representatives here at Studica, if you're in the US, you can call us. This is the office I'm at. It's 888-561-7521. If you are located in Canada, you can call their office. It is 800-561-7520. Of course, in both cases, it's a toll-free number. If you'd like to find out more about these or any of the other Fischertechnik education sets, and we have quite a few at this point, you can go to www.studica.com/Fischertechnik. That's FISCHERTECHNIK-education. You can also email us. I'm going to give you two email addresses. First one is on the screen right now. It is info@studica.com. That's easy enough. You can just write us with any general questions you might have. If you do have any questions about anything I've talked about today, anything specifically Fischertechnik, anything you might not be thinking of now, but you think of later, you can also email me directly. My email address, it's not up on the screen, but it is Lance Z. So that's LANCEZ, my last name being Zurich, so just take the Z, Lance Z at Studica, STUDICA.com. And I will be happy to answer any questions you have. When we get done with this, Christy will also be sending out, probably tomorrow, she'll be sending out a link with the recording of today's presentation. And you can also reply to that if you have any questions or what have you. So anyway, on that note, I'd like to thank you for taking the time to attend today. I hope you all have a great day, and I look forward to hearing from you soon. Take care.